Okay, good afternoon, everybody. We've come again today to discuss some certain questions on rectangular glass prism. You know, this year WAEC 2025 is number 2 is on rectangular glass prism with mirror. Number 3 is on electricity, which is potentiometer, and the number 1 is you have the G clamp and Hooke's law, combination of G clamp and Hooke's law. So, but let us solve this question as part of number 2, that is the rectangular glass prism. Okay. A point source is placed in contact with one surface of a glass block of thickness this and of refractive index 1.6 is viewed along the normal to the opposite surface. By how much does the point object appear to be displaced? Now you have refractive index is giving us read depth over apparent depth. You have the apparent depth, okay? So the refractive index is giving us this, that is 1.61. The read depth is giving us this, that is 1.6 over apparent depth. You have the apparent depth, okay? This is the apparent depth. So I'm going to make the apparent depth the subject of the formula. If I do that, I will have apparent depth will give me 1.6 over 1.61. Okay, so if I divide this, I'm going to have 0.994 centimeter. That is the apparent depth. So what I'm going to solve now is apparent displacement, and that is what is asking the question. So let's solve it. Read depth is giving us apparent depth plus apparent displacement. Okay, so the read depth is 1.6. 1.6 is equal to apparent depth is this one, 0.994 plus apparent displacement. That is what we are looking for. Apparent displacement. So I want to make the apparent displacement the subject of the formula. That will give me apparent displacement will now give me 1.6 minus 0.994. So if I subtract that, I'm going to have 0.606 centimeter. So this is the apparent displacement. Thank you.